Here's a riddle for you. What is so fragile that when you say its name, you break it? That would be silence. Alright, here we go. Just going to do some examples. Some of the problems that you'll see in the AP exam might look like these. Normally you're not going to see the examples from like the last video that I did. You're not going to see problems like that where it's going to say, here's a function, how big can that function be on this interval? That's not that's not an AP level problem. The AP level problems are these right here. The problems that we were doing in the last video, those are parts of these AP problems. So hopefully you're understanding that the hardest part is finding that capital M and in the Lagrange error bound. But once you find that capital M, then you plug it in, and then you just well, I'll show you what you're supposed to do, but that's the hardest part, is finding that capital M. And because you have to find the n plus first derivative, evaluate it on an interval, and find how big can that n plus first derivative be. Now, all that being said, I want you to keep in mind one thing. If you're being asked to find the maximum error, or an error bound, or however they're going to phrase it, or even, I should point out that you might see this. Remember that f of x is equal to the polynomial, depending on the, let's say it's a fourth degree polynomial of x, plus the remainder, the fourth degree remainder, and that's a p right there, where you might be given, they might subtract that p of x like this, and have that equal to r4 of x, and they might just say, well, what's the maximum value that this can be? They won't even say error bound. They'll just have that thing right there, and they'll say, what's the maximum value that can be? Or they'll say, show that this right here is less than or equal to some number. They'll have some number, some real number. And so you have to be able to interpret what is being asked. And all of these things basically are asking the same thing. They're saying, well, how big is the error when you use this polynomial to approximate that function? Okay, so that being said, we have our first example here, first real AP example. Find an upper bound for the error of the approximation of the cosine of 0.3. So in other words, we have used the Maclaurin series for the cosine. And in fact, we're only using the first three terms of the Maclaurin series for the cosine. And remember, Maclaurin is centered at 0, and 0.3 is where is the x value, the real number that we're approximating the function at using the polynomial. Okay, so the function being cosine of x, we're using the first three terms of the polynomial to approximate the cosine of x at 0.3. So, how big can the error be? Well, all this talk about Lagrange, the Lagrange error method is great and everything, but the one thing I want you to keep in mind is that normally when you're being asked to find the error, it's going to be an alternating series, okay, which totally eliminates the need to do Lagrange error, and I'm going to point that out here in a second. So the cosine of x being an alternating series, the polynomial approximation alternating in sign, so positive, negative, positive. Okay, that's great. And the thing that you should write down, and the thing you should remember, it's going to save you a lot of time because it's a lot easier to do this if you don't have to find the maximum error, if you don't have to use the Lagrange error method. If f of x is an alternating series, then the maximum error is the next term. Okay, so that's how we do it. And you have to point that out. You have to say, since it is an alternating series, the maximum error is the next term. You say that, or actually we say the absolute value of the next term. If the next term is negative, we don't say the maximum error is negative. The maximum error is always going to be a positive number. So it is the absolute value of the next term. And I really shouldn't have put this here, x to the 6th, because we already knew that we're approximating at 0.3. So when I put the x there, I wrote it in pen, so at x equals 0.3. Really, it's just 0.3 to the 6th power over 6 factorial. If you look at the series, notice that the polynomial, it goes up to the 4th degree. And remember, for the cosine of x, the cosine, the terms in the series are all odd or even powers of x. And so since we're using the 4th degree polynomial for the cosine, then the next term would be the 6th power of that x. Okay, so x to the 6 over 6 factorial, and that's what we have here. Since we're using the cosine, the polynomial to approximate cosine of 0.3, then we just plug in 0.3 for x, 0.3 to the 6th over 6 factorial. And that actually, it comes out to be 1.0125 e to the negative 6. So on your calculator, that's what you would see. You probably know what that means, but I thought I'd go ahead and explain it anyway. This is really 1.0125 times 10 to the negative 6. That's just calculator language for that. And so you take that decimal and you move it to the left 1, 2, 3, 4, 5, 6 places. And any empty little buckets, as my 3rd or 4th grade teacher said, any empty buckets, you fill them with zeros, and you get this number right here. It's a really, really small number, and that's the maximum error. So it's actually a very good approximation for the cosine of 0.3. And there you go. Catch you in the next video.